All right, welcome everybody. It's the WebAssembly filters meeting for the 26th of July, 2021. It's a Monday. We've got about 45 minutes set out to discuss this topic. And well, we did have a healthy agenda. It looks like Anirban he's not on the call. And I guess his agenda item went away. Maybe I'm behind on some Slack messages on this. It looks like I am. Okay. All right. So he's got a conflict today. He won't be able to make it. Anybody else have topics for today's discussion? Drop your name into the meeting minutes if you would. Ashish, while you're poking people, do you mind poking Gaurav Chadha? Oh, no, he's on. Okay, never mind. Poking not necessary. So good. Well, so let's rearrange the schedule. So Nirban is next time on Envoy's capabilities with respect to traffic mirroring. Utkarsh is joining. That puts Gaurav toward the top. And then I've got a topic to discuss on filter support across various service meshes. Who else do we have on? Okay, good. So Utkarsh is joining in a second. While we take attendance, let's go ahead and jump into our first topic if we can. I see. Okay, so Utkarsh is having, all right, so let's bump up Lee's topic to the top. So Gaurav is getting ready and then Utkarsh is as well. So good. So anybody on the call for the first time? We got Vishal, Shubham, Rudraksh. Tunjay, Ashish, Anshu, Aditya. Okay. I know we've all had a chance to speak before, and so good. Hopefully most of us have had a chance to be introduced to the others. Ritanjay, you and Shubham, the two of you might be the winners in terms of being the newest. Have you guys been on this particular call before?
No, sir. This is my first call in this topic.
Okay. Yeah, good deal. Do you want to say hi real quick to everybody?
Everyone, I'm Rityunjay. I recently joined 2 weeks back. Right now, I'm working with Nikhil on a LearnNG topic, front end. And I'm learning Meshery and microservices. So I thought I should join this topic.
Perfect. So Ritanjay, actually, as you go through those learning paths, at some point, we'll have content for specific to WebAssembly filters. And so good. You're paving the way for others to learn. Okay, and Shubham, do you want to say hi? Oh, okay, you were on last week. Okay, very good. So no, you already did. All right, so the first topic at bat then is with respect to how it is that Meshery orchestrates filters, and Utkarsh is going to walk us through this end to end. So I won't explain how it works because he will. Instead, what I will say is Meshery is in the process of all of its adapters supporting management of WebAssembly filters. Most notably, it's the Meshery adapter for Istio that has the most advanced support for filter management. Second to that, I don't think Sayatan is on, but Rudraksh is. Rudraksh, do you want to tell us about the status of, like basically pattern support, filter support for the rest of the adapters. And maybe we'll find that folks like Ashish are interested in jumping in on that.
Yeah, so basically we are doing some work on generating pattern components automatically for every service mesh. So that would be where we would be handling all the filters. Recent call for volunteers were made for this. Can't find the link. Sad.
Yeah. Okay, so I'm trying to put in a check mark and I can't find this stinking thing. But so the Istio adapter is well on its way and is managing actively and has been actively managing Envoy filters for a long time. Sayatan and Rudraksh have been adding that support to Open Service Mesh, as well as I believe to Kuma now as well. So,
yep.
Okay. Which leaves us with, I mean, there's still some work, I think, to tie off on Kuma and Open Service Mesh, but it leaves us with Kuma, console. These are the big five, but it does leave us with all of the rest as well. So the Citrix Service Mesh, Nginx Service Mesh. There's a, yeah.
Basically all of them initially which use Envoy proxy in their data plane.
Yep. Even outside of that, support for non-Envoy proxy data planes like Linkerd, Nginx Service Mesh. These two will still need to add pattern support, which if you're adding filter support, you're more or less adding pattern support at the same time. And so on that,
I think with Istio, the way we have gone is Envoy filter is a CRD for Istio. So we have been able to construct a pattern based on that, but not all other service meshes have a similar way of putting Envoy filters.
Yeah, right. No, actually, none of them do. Yeah, you're right. You know, let's explain more on that point and how to approach it after Utkarsh walks through the filter management capabilities and how those are pattern based. I think it'll make a lot more sense to everyone else, and then we can talk about how to ramp up this effort to complete it for the rest of the adapters. Utkarsh, do you want to take us through it?
Yeah, just actually I'm setting up my system. I just rebooted. Okay.
You guys, so we have Rudraksh, there's an open PR or two on Open Service Mesh and Kuma on this.
Yep, there is one open PR in Open Service Mesh adapter, as well as the workflow has been merged in Istio. So I'll dig up the link.
Okay, so I got the one for Open Service Mesh. So the approach here is something I want to talk about after Utkarsh walks us through it, because I think there's a couple of approaches to providing this type of support, and so worth reflecting on. But yeah, Utkarsh, whenever you're.
Yeah, actually I wanted to demo the entire thing, but the pod are initializing for like past 2-3 minutes. I can start like maybe showing the pattern. And let's see. The deployment is ready by then. Okay, so let me. So this is a pattern that I today even in fact shared in the WhatsApp channel also. What this pattern is doing, as in fact Raj was mentioning, is a bit Istio specific right now, but the name also says the same. That is, this particular pattern is actually Istio specific. It says Envoy filter Istio. So the implementation is also Istio specific. What we are doing in here is first initially I'm applying. Basically, I'm setting up Envoy. I'm setting up Istio so that it can instruct Envoy for configuration discovery and those kind of things. This is required because, I mean, this is how actually Istio sends the configuration to Envoy. So this is the first step that I'm doing. And after that, I'm actually applying the rate limit filter. This rate limit filter is being grabbed from here. That is the layer 5 organization. We have our image of repository, and there is a rate limit filter. So basically, I'm instructing that, hey, go ahead and grab this particular OAuth filter from this particular URL and with this particular configuration, and basically use that. I'm also instructing it to first ensure that first it applies this generic Istio filter, which actually sets things up. And after that, it will go ahead and apply this rate limit filter. And if the deployment is ready, which it is, so what I should be able to do is run mystery-CTL pattern apply this particular pattern with my token, and I hope it works. Yeah, it said that it created these particular things that I asked for it to create. Let me check. For some reason it's not responding. So I think the Envoy proxy actually received the configuration. I'm not sure why it's not reachable. Image.
You need to specify the port as well.
Actually, I'm using the Ingress gateway, and the gateway should have been configured when I actually I provisioned the application from here, and when we actually provision the application from here, we also patch. We actually generate a gateway configuration also. What I would expect is that when I send the request to imagehub, imagehub.mystery.io, it will go to this particular Istio's Ingress gateway, which will actually redirect it to the actual service, which is not responding. That's strange. It's interesting. Okay, so let me do this. I think the issue was because of the filter. So this is also a demo for the delete command. If you would actually you can actually delete the pattern that you applied using the apply command just by doing delete. Let's see if it's accessible now. Just to okay. So it's not because of the issue with the pattern. Probably something's wrong with my setup. So it's a bad idea to tinker with the system before demo, which I was doing.
Yeah, no. And you have local entry hosts, and yeah.
So, we can probably shift it because I
yeah,
think
no, yeah, good. Actually, it sounds great. Yeah, actually, the demo is just like cream on the top, like not necessary. Just, but to the point of discussing how the fact that other adapters need enhanced to support filter management as well as just pattern management in general, I think it's a good, seeing some of this is helpful context for everyone. So, and that's to say that in each adapter, the purpose of having a mesh readapter for a specific service mesh is to have service mesh specific support. So I like, that seems pretty obvious, you know, in terms of the design, but to reinforce that, as there are individual operations and management tasks that each adapter can perform for each specific service mesh. Not all service meshes are made equal. Some do different, you know, they do different things. And as such, each adapter needs to interface with those service meshes differently. We're trying to, it's hard to sustain 10 different, supporting 10 different service meshes. And it's, we certainly don't want to hard code really as little bit as possible, because each individual service mesh has changes over time. They have new releases coming out all the time. They're adding new features. And so to be as dynamic as possible in supporting their capabilities and exposing those capabilities to users, there's the approach that we've taken is an acknowledgement that all of the meshes that we're looking at run in context of Kubernetes. Some of them support workloads running outside of Kubernetes, but all of them minimally support microservices and, you know, containers running on Kubernetes. As such, most of them have taken a common design pattern of creating custom resources. So Kubernetes custom resources. They each come with different custom resources, hence the word custom. The thing, and so whether they come with a custom resource or set of custom resources or not, the service meshes themselves, they are often, like when they are deployed onto Kubernetes, their deployment is described as a set of manifests, a set of Kubernetes manifests, and which is a set of YAML. YAML is another form of JSON. Buried in those manifests is a description of how to configure that service mesh and what resources that service mesh manages. Good. So actually, if Meshery and each Meshery adapter analyzes the Kubernetes manifests for its respective service mesh, that adapter can dynamically extract information about what things are configurable for that service mesh and what custom resources that specific service mesh manages, and what are the details of those custom resources. So by parsing through YAML, by working with that JSON and extracting schema definitions for those custom resources, Meshery can dynamically, the Meshery adapters can more or less, that's the way in which we don't hard code what operations and adapter supports. It should be dynamic based on what service mesh is being deployed, what version of that service mesh is being deployed, and those are the operations that should be exposed in Meshery in the UI. Okay, so to sum up what I just said is, the Meshery manages a lot of service meshes. Each service mesh is complex. They each have their own capabilities. They each have their own versions. Keeping a compatibility matrix of support for all of those things oh, it takes a small army. Fortunately, we have a very warm and welcoming community that embraces what is currently a small village and is building toward an army that can sustain these things. But even at that, we want to be as intelligent as possible and be excellent software engineers by being as lazy as possible. I mean, being as smart as possible and not repeating ourselves in terms of the code that's written in each of those adapters. So each adapter, okay, so with that in mind, each adapter needs to grab a copy of the Kubernetes manifests that belong to its specific service mesh, run a utility against those Kubernetes manifests, extract info about those managed elements. So Sayatan and Utkarsh and Rudraksh have been working on they have been working on adding that extraction up, the process of extracting that information. They've been adding it to the build process for each service mesh adapter. So that's what we were just talking about. Rudraksh was saying, well, there's like 3 adapters that have, that this type of support is being built for. Good. That means there's 7 others that need that type of support. So one, we should talk about what that current model is and explain it to others so that Ashish, who has volunteered, I don't know how many times to work on a Meshry adapter to go be able to do this, and anyone else that wants to do it as well. And I say this very jokingly because Ashish quite literally has never asked to do this, but I think that he's capable of doing it. And so I'm going to volunteer him. And then anyone else that wants to do this as well. So there's one thing for us to do, and that's to go look at like the open PR that Sayatana has on Open Service Mesh. Look at what that build process looks like and how others on the call can take that forward. The second thing we should look at is a discussion around the fact that the need for Meshry, for an adapter to understand, to understand how to manage a service mesh, that building that in at build time of the Docker image that we create for the Meshry adapter, that's good. That's helpful. When you download the adapter, it then knows how to perform operations for some certain set of versions of that service mesh. But over time, as a new version of that service mesh comes out, you either need to download a new version of Meshry, or you'll need to run that same, Meshry might need the ability to run that same process that it does during build time to run that same process at runtime. And so that would be our second conversation. So, Utkarsh, do you have other things you wanted to tell people? Else, we'll talk about the build time stuff.
Yeah, just one last thing, and that was the caveat that although this thing works, but this particular implementation, this particular implementation actually relies on a feature which was introduced in Istio version 1.9. So anything before that so basically this particular approach is almost right, but in that case, Envoy would start complaining because it would expect a cluster to exist. That thing came into existence only since 1.9. In 1.8, this particular approach doesn't quite work. So it will work. You can get it working by defining a custom cluster in here, which has outbound access. So if you by cluster I mean the Envoy cluster, not the Kubernetes cluster. You can actually define a cluster in here, and then it will work, because in that case, what will happen is that everything would be handled by Envoy. What Istio did in version 1.9 is basically, even right now, what happens is that Envoy reaches out to get the WASM binary. But actually Istio agent intercepts that request and then grab the filter, grab the binary, it can do the SHA-256 test, which is the next step. But because we are not providing it enough, so Istio won't do that. But it can do that. And once it grabs the binary, it will give it to Envoy. So in that case, Envoy doesn't need a cluster. But this was again introduced in 1.9. So yeah, this was a caveat of this particular approach. That was actually the last thing I would have said after showing that, hey, this works.
Yeah. That cluster that you're referring to an Envoy cluster?
Yeah.
And okay, the SHA that is needed there, what's our current approach to providing that support in 191?
In what?
Well, or how are we overcoming this?
Supporting Istio, well, let's say Istio version 1.8 is that?
Yeah.
Yeah, so actually in that case, right now, this particular approach, as I said, was only for 1.9 or later, that is only two major versions, 1.9 and 1.10. If you want to support anything before that, then we have to actually rely on Envoy's capability, in which case a lot more configurations would be required in here. Now, this particular pattern, as it is, would work only in the latest one. A few more configuration would be required in here, like cluster, the timeout, SHA-256, and yeah, actually these three attributes are what is required. We can actually create patterns for those service meshes. Let's say we detect that the service mesh that is running is actually the older one. We can actually do that. The only issue is that because Envoy is being directly controlled by Istio in this case, so configuring a cluster on the fly is something. I mean, I'm not sure if we'll be doing that, but we can. But if we do that, then we actually kind of we kind of start configuring Envoy at its core. But definitely we can, because the default outbound cluster that it has, none of them can actually reach out to the internet by default. Actually, I was looking through the configuration that the default configuration that Istio provides to Envoy. I didn't find a cluster which has outbound access to the public internet. So that's our issue. We can definitely reach out to Envoy and create a cluster, but it would be too much of things. Also, Envoy in their code, they have mentioned that they know that there is an issue that you have to, in order to support this thing, because this configuration just goes to the Envoy almost as it is. So, so they have comment in their code that they know that this is an issue that you need to have a cluster in order to get things working. So they've said in there that they will actually fix it in future so that they can resolve DNS. Inline DNS is what they called it. So probably in future Envoy proxies, we have this support built in. But for now, either the way is to use Istio's latest feature, or provide basically tweak Envoy configuration so that it has a cluster which has outbound public. Or the third third method is the method that we were actually using, and that was to basically patch the deployments so that it has basically it has a persistent volume. In that volume, drop in the WASM binaries and configure the Envoy to load the WASM from that particular binary. In which case, this particular thing would become actually local, and the code will actually reside in the local volume, which the proxy can actually refer to directly. The reason this was not the first approach was because this is so the thing is that it will require processing on the adapter side, and it would be the most generic solution to the problem. So that is why we were at least I was trying to get to a solution where we can actually use WASM Envoy's core functionality to load the WASM binary. That is the last approach. I think it's the most it should work in most of the cases, unless and until someone doesn't have a storage provision or something in the cluster running. I think that would be the only issue. That would be the only time someone would run into an issue. if they don't have a CSF plugin or something.
And that more universal approach of patching their deployment by attaching a volume, creating a volume, attaching a volume, that would I guess good. That falls in line with what Joshua, who's been on the call for a while from Oracle, he's looking for permission to share their use cases. So hopefully next week. And that includes like direct management of Envoy and direct management, and then their end direct management of filters, which could be done in a couple of different ways, like you were just describing, but that more universal way. Do you anticipate conflict with later Istios? Like if that CRD is would we then not be able to list an Envoy filter as an Istio custom resource because it's going to want to configure this differently?
I don't think there would be any kind of conflicts unless and until someday Istio decides to remove this or change this particular CRD entirely. Because in that case, what we are relying on is again Envoy's core functionality, and that is to be able to grab the WASM binary from local file system. In Kubernetes case, that turns out to be a volume, persistent volume.
Okay.
So I don't think, unless and until someday it decides to remove or change this particular thing, the entire thing from here, then definitely we will run into a conflict. Other than that, I don't think there should be an issue.
Okay. And the current filter management that we have, or the mesh adapters operation, it patches and adds a volume. Correct?
Yeah.
So that, okay. And
so if we do it from here, yeah.
No, go ahead.
Yeah, if we perform the operation from in here, it will actually create a volume, and it will not that. So doing it from here won't work right now because there was some configuration issue that I actually encountered today, earlier today, which was Raj actually basically told me that why there was an issue. Any fixes needed in the Istio wrapper for this. When you used to click in here, what used to happen was what exactly happens is that we actually get a volume, we patch the current deployment, whatever you have, and we drop WASM binary there so that Envoy filter can actually load it.
Good. Yep. Good. I wonder how often it's the case that a given Kubernetes cluster wouldn't have, wouldn't allow a volume to be created and locally attached, like a local volume specific to that node. Because this isn't we're not talking about a PVC, a persistent volume, or I guess a PVC local to that node, maybe?
Yeah.
Okay. Yeah, I wonder how often we would run into that. It wouldn't seem like that would be a big deal. Okay, good. This that's great. So if we move on, any other questions for Utkarsh before we go to the next talk? Yeah, it's good. So if you're sitting on the call and you're like, you have no idea what's going on, then that's probably the majority of us. So, but you'll learn, or we'll get there. So part of getting there then is looking at more at how it is that the adapters are providing this support. So, Saitan, do you want to take us through that?
Yeah, Lee, sure. I can give a walkthrough of that. Yeah. Can I share my screen once? Actually, this is the PR which I generated. So this is actually generating the workflow to generate the JSON schemas and definition for the OSM component. We are generating a workflow to generate those JSON schemas and the definition. So this is the workflow actually. In the GitHub workflow, I am adding this file update omdefs.yaml. And under that, we are performing this checks. Like if you see this one, actually, these are the things that are going on inside. Like check the OSM version and generate and push the VM definition. So by checking the OSM versions, there are these 6 steps which you will get over here. So yeah, you can see. So first we are checking the OSM version. From the actually this OSM version is now hard coded in this .env file under the GitHub. So it's currently OSM version 0.9.0. Next, we are getting the release tag. Then we are checking out the code, and then we are getting this jobs done. So this first job is actually to check actually the versions of the OSM, and we are done with this. Then the actual steps start. We are generating and pushing the OSM OM definitions. So from here it starts generate and push the OM definition. So the actual steps start from by getting the OSM manifest that Lee was talking about, like those CRDs. Now, if you want to check out the OSM CRDs, it was in over here, like in the OSM repository under the charts, OSM and CRDs. We had this all CRDs files over here. So actually, we need to collect all these files and get all this CRD. So we did it like so there was not a proper CLI command to generate those manifests. Like in Istio, we had a command called istio-ctl manifest generate, and it used to generate the manifest. But OSM, we didn't have that. So we actually made a OSM CRD folder and then went inside the folder and just downloaded all those 7 files in this one go. So in this OSM folder, we had these 7 CRDs. Then we just merged all the OSM, all the YAML files together in this OSM.yaml file. Next, we are using this QOpen API JSON schema to convert the Open API to JSON schemas. Actually, this is a node-based CLI, and here is an example how we use it. So we are using it over here to get those schemas. So over here, we are building the JSON schema, like we are downloading that, we are cloning that QOpen API, and then we are installing all the dependencies over here. After that, we are generating the workload definitions. So if you want to see this workload definition, I can show you. One minute. Over here. So actually, these are the workloads, and these are the JSON schemas and its definitions. So these are generated after running that command. These are the JSON schemas. So, this is actually done over here. Like we are running this command.
Good. Thanks for this. I'm sensitive to the fact that some of us on the call might be lost already, and so I figured I'd interrupt and ask, like, hey, who's got questions on this? Like, who can articulate what they think is going on? Just high level, like, what's the workflow do? I will say this: you don't get this kind of opportunity on most other CNCF project calls. So like, it's a good one to learn.
So Lee, can I try like in one words what is actually going on? So that,
okay.
So actually what in one words, if we want to say, so actually we are just generating the manifest file from the respective adapters, GitHub, and we are just generating the manifest files. After that, we are building the JSON schema, and then after that we are generating the workload definitions. So these workload definitions are actually over here. This is the actually workflow to generate these schemas and definitions.
Cool. Ashish, you're up, man. Can you answer my question?
Yeah. What question?
Can you characterize that workflow and what it's doing?
Yeah, he did not complete it. Up until where I was following him, he was downloading all the YAMLs, and after that, I kind of lost him where he went with that. So he downloaded all the YAMLs, and then he merged it into one YAML, and from there he was okay. So there's this action actually builds that particular JSON schema for it. Okay. And then he's generating workload definitions.
Yeah, that's it. That's actually the thing. That's the, I mean, yeah, good. Which is to say, this fires off at build time when we're building the image, like building the mesh adapter, and it kind of does those two things. It like grabs the installation manifests for open service mesh in this case, runs a utility against them to pull out the JSON schema definition of those custom resources, rejiggers them by echoing, by echoing things into a different format, applies some JQ and persists them back to the repo. And like, great, yeah, it's more or less that simple. It actually can be, and so good. So we need to take this, copy paste it to other repos, and then swap out where it says open service mesh CLI, swap in like Kuma CLI or Linkerd CLI or Now that said, what value is the open service mesh CLI providing as opposed to the manifests themselves directly? Or are we not using OSM CLI anymore?
No, OSM CLI doesn't have any way to get those manifests. So we are using the GitHub API to fetch those charts and CRDs from OSM's reports.
Cool. All right, good. This is perfect. This is going to line up my my argument very well, which is we do want for the mesh adapters, when they ship, for them to be capable of managing that service mesh. So they should have and understand, they should have these patterns, right? Or they should have these, these schemas in hand, right? And hopefully for a number of versions of that service mesh. Good. That way, if you're running in an air-gapped environment, you can just start managing meshes. The bash that we have here, this workflow that we have here is, well, we're repeating ourselves, aren't we? Which is to say that in the adapter itself, there's an operation to install the service mesh in every adapter, right? It's pretty universal. What does that operation do? It goes out, downloads the manifests, just like this, from GitHub, and then applies them to Kubernetes. And so actually, if we augment that operation to download the manifest, which it already does, but then just run this utility and parse through, do the things that we're doing right here, then not only could we invoke that at build time, because we can just invoke that function from here in this workflow, but we could also invoke it during runtime. discuss amongst yourselves, like, thoughts on that. What do you think?
Yep.
Well, see, now that's no argument.
Can we just extract all those bash commands in a script, even if we duplicate the script, and just use first, let's say, 2 parameters for the source location, the folder, let's say at the beginning to have like 4 scripts. I don't know, grab sources, run utility 1, run utility 2, and serialize all together back or something like that.
Yeah, yep, that
just
would
in
work.
order to contradict you or to make a contradiction by saying something after you. Also.
Good. Yeah, no. Yeah, good. Actually, so that approach, like, I'll take that thought that you just said and shift it a little bit to something like this. Well, the oh gosh, what's the word? The sophistication of the thing that you just said is that, well, you could actually just run one workflow that parallelizes this task for all the supported service meshes. So you could just go, in one swoop, like grab them all, extract them, get the info you need. You could also build in support for different versions of each of those service meshes, because that schema, that JSON that gets extracted might be a little bit different between those versions. And so, yeah, you could sort of centralize that and have it, so no, but the reason that that's not being done, I mean, like that there's value to that. Like, and what I was trying to highlight is the fact that, like, what you've said is an improvement, like, upon what's being done here. And there's merit to it, and does have a place, and potentially is something to do. To Adina's point, there's one portion of this script currently that is written in Utkarsh, remind me, this is written in Node.js.
Yeah.
Okay, not Golang, and it's like the linchpin to what's being done here. It's the thing that's performing the extraction of the JSON schemas. And so Utkarsh you wrote a Golang based CLI to wrap this, if I recall.
No, it uses Nexi to convert it into an executable, because the idea was that probably Golang can use that executable internally, so that we can do all of this thing and basically during the runtime. So Nexi is being used to generate a executable.
Okay. Is there also a custom CLI that's been written? Or no? That Cube Open API JSON schema repo? Does it have a CLI? I thought it did.
Actually, those steps are building the JSON schema utility only on the action runner, because we haven't released binaries for this yet. So if we release these binaries, we'll not need to build them, if that's what you were concerned about.
Okay, good.
I didn't realize I was on mute. Actually, I was saying that, yeah, that is actually a binary. As Rudraksh was saying, all we have to do is make a release here, so we can use that CLI, that is Cube Open API JSON Schemas CLI. Right now, what it's doing is over and over cloning, and then creating the binary during the workflow, and then using that particular binary to generate the JSON schemas. What we can do is just release the binaries so that we can use them either in the workflow or
Yeah, sorry, go ahead.
Yeah,
I just don't know why we
yeah. So we can use it either in the workflow or probably, or maybe ideally from Go. Every time when it registers, what we can do is we can just grab that binary and do these things in the Go, in the adapter, and then send those JSON schema for registration process.
Awesome. So good. Who is going to continue to work on this?
I guess I'll have to.
Yeah, good. Rash. And Aditya, good. And Sayatan and Ashish, good. Okay, guys. So we're gonna and then whomever else wants to give this a go. There's a couple of things that we need to change around. And so please, to what Adina was validly doing is like presenting an alternative. Please present an alternative if this, what I say just now, doesn't resonate. And so that is to like, see, here's the thing is when this runs and then we persist these patterns, these components, that conceptually that only has to be done once for that version of that service mesh. And so, in concept, like if we go run this for all of the service meshes, like to Adina's point, then we're good at supporting all those other versions. Anyway, the problem is that new versions will come out. And so then we'll need to support those potentially on the fly. Okay, so there's a couple things that need to be done. One is that, are we versioning the components today?
Yep, we are. Okay. Like the service meshes version gets appended to the JSON schema.
Great, okay. And then that gets registered as the adapter registers with Mesh Server, that version information gets recorded, right?
Yeah, it does get recorded, but right now Mesh Server uses that information. That's something on Meta to do.
Gotcha. Okay. Gotcha. By the way, for just as something else for all of us to look at, maybe as we talk through this, is there's an architecture, a mesh architecture deck that will visually walk you through what we've been discussing. So hopefully you can grok it a little bit better. Uh-oh. I hope no one deleted the slide. So there's one slide, but that's not it.
Last edit by Jibril.
Uh-oh. Yeah. I don't know. I guess that's so whenever someone joins, we give everyone edit access because we want everyone to get engaged and feel warmly welcome. Okay, so we're gonna have to, unless I'm missing it, something might have gotten deleted accidentally. We'll have to go back through that. Okay. Well, in the meantime, everyone can look at this. This is close, but not what. Yeah, we absolutely have to find that slide. Okay. Anyway, so guys, as we go to wrap up here, because we're at the top of the hour, there's a couple things to do. One is make sure that versioning is that as the JSONs, the schemas are extracted, that they're versioned. Today, are we doing that with just not with a folder name? Are we doing it with a folder and including that in the JSON itself?
Yep.
Okay, good. So that's perfect. The other thing that we would ideally do is, transition this out of, well, leave the workflows as is, but is to build in this capability as a runtime operation as well into the adapters. And then in the workflow, instead of running the bash scripts, we would invoke the Golang capability in the adapter itself, which would mean, potentially spinning up an adapter and using gRPC to invoke that operation, or using whatever to invoke the operation. You can see examples of how that's done with console, Meshread console. There's workflows that will spin up the adapter and invoke its gRPC operations. I think under tests, and it's using bats here to do these tests, and using this gRPC curl to invoke those commands. So that would be relatively easy to do. And so Mritanjay, if you're looking for a link to the presentation, the link is in the chat itself. And if you can't access it, then you'll want to fill in your community member form, and you'll get access that way. So Utkarsh, does this, is that true what I said, that we would have to, in the workflow, we would have to spin up an adapter, have it running in order to invoke its operation?
If you are doing it in the workflow, then yes, but probably we can do it, instead of doing it in the workflow, we can do when, right now what happens,
it just doesn't
when
support
adapter boots up, it tries to register its capabilities.
Air gap deploys aren't supported.
Okay.
Yeah.
Then
can
in that
ship,
case we will have.
I guess we can ship two kinds of Docker images, one for air gap deployments and one for normal.
Yeah, we could. But if the purpose, what justifies doing that is actually including a full copy of all of that service mesh's installation files, not its containers, but all of its manifests and its CLIs if needed. Otherwise, the Rudraksh is a great suggestion. The reason that it's not justified to have a separate one for the JSON schemas is because they're so small anyway, that from here on out, we should start supporting the current version and on forward, and persist that in the image, since it's small. The footprint is very small. Right?
Yeah, makes sense.
But to your point, like, there is a need, and people have asked for like an image that's wholly contained and has all of the ability to manage deploy the service mesh and manage its lifecycle fully air gapped. It's like, well, that's yes, we want to support that and do, but most likely what will happen is there'll be instructions that say, okay, so here's how you configure the adapter to point not to github.com or not to Docker Hub, but rather to your local registry, and it will retrieve containers from there. Or another alternative approach is to have them run Meshread Cloud on-prem and have it serve up, be an artifactory, or have it serve up artifacts. And so. Good. So we already have support for multiple versions. Building this into the runtime and Go is the ideal, is a good goal. It doesn't mean that we have to remove the workflows that have been written today. Those should be merged and run, and we should then provide pattern management and filter support for at least those 3 service meshes that we have currently. If that workflow is easy enough to copy and paste to 2 or 3 of the other adapters, I think that's fine, that we would add the initial pattern support in the same fashion that we've just done. I think that's okay. And then that way those become manageable through this service mesh pattern mechanism. And then over time, we can build in runtime support in Golang for, doing what we were just talking about. Does that sound, is that confusing to anyone? Does that sound not appropriate? Gaurav, I forgot that you had something to share, that we pushed it off. Do you want to?
Yeah, I can. Yeah, quick share.
I know we're over time, everybody. So if you've got a conflict, feel free to drop. But otherwise, I'd love to see what Gaurav has done.
Yep. So for the filters, I have added a multiple selection option within the rows itself. So we can select many rows at a time, and we can just delete. So currently, I think I should not delete all of this. So because we are on the Mystery Cloud server, so yeah, it's get deleted. So, and this was a quick update from my latest PR, and talking about the previous update that I was supposed to demo on the Watson for itself was that I updated this deleted to the actions, and over here with just some addition to the icons over here. And one thing I want to ask, maybe Utkarsh or Navindu would correct me. So about that deployment for the filter, since we are using the pattern format here in filters also for deployment. So for the deploy endpoints that we were using in patterns was /API/experimental/patterns. So should I also add this endpoint in the filters also, or we'll have separate filter endpoints for that? Because currently I haven't added the patterns one, so the deploy won't work for now.
Say that last part again. Should you add what?
Should I add the patterns endpoints for the deploy functionality over here? That because we are using the patterns for the deployment of the filters. Pattern files.
Yeah. So I hear what you said, and I'm having a hard time imagining this. Can you go to the patterns UI? Okay, so a given pattern might describe a filter and highlight the fact that, yeah, okay, now I think I get okay. As a refresher, just for me as well, that the patterns here, these are YAML. These are YAML manifests. This is basically what a pattern is. Okay,
yeah.
good. And you can describe all kinds of things that you want to configure for your infrastructure in these. Okay, good. Now, one of the things you might describe that you want to configure is the deployment of a filter, and the filter being a binary. So under the filters table, what we're dealing with here is not manifests as much as we're dealing with, primarily with binaries. And yeah, there's a little bit of configuration that goes with it, but primarily a binary. And so would it make sense to that play button that you have, if people click it today, what does it do? Yeah, I don't know. I don't know that that's like in the future that might be appropriate. At the moment, we might leave this as just binary up, CRUD on these binaries, and the application of it to a mesh, maybe we would leave that in the patterns UI and also in the actual service mesh management UIs.
Yeah.
Does that make sense to everybody? It's not that potentially applying filters from here or deploying filters from here it's not that it's inappropriate. Like, yeah, sure. I mean, like that. It's that it's a little bit of a harder user experience to design, and clearly we're not there yet. So maybe just trying to get it correct in terms of how that experience happens in the patterns area. And then once that's done and things that maybe come back and ask this question again, okay, like from this starting point in the filters interface, does it make sense then to let people apply these? Like one thing that does make a ton of sense here and would be really interesting to see is, so great. So we've got these 3 different filters, and we can manage their lifecycle. We can upload them to Meshry so that Meshry can deploy them, so that you can deploy them using a pattern. Good. But, well, geez, I can't remember, like, is that test filter being used anywhere? Is that actively deployed? Gosh, I can't remember. Boy, I wish Meshry would tell me that. Like, huh. And so that is certainly something that is relevant, that is appropriate to expose in this UI. And so, Nivendu, do you have an idea as to how that would be done? I mean, not that we have to go work on this. I'm just curious if people are familiar with what we would do.
For deploying filters?
For just showing the number of deployments of a specific filter. So how many times is that filter deployed currently? Like how many active instances of that filter are out there?
Currently, like we don't track, we can't apply filters from the UI, right? Like we need to use patterns, right? So once we have that, like I think we can track it.
Good. So MeshSync will discover these, and it's something to go look at. Like in the current MeshSync database, like if you've got a pattern deployed, is that data readily available? And then great. If so, Utkarsh, the relationship that gets created, the quote unquote MeshSync ID.
Yeah. So because I anticipate that filters will eventually, like they do use the patterns workflow. That patterns workflow is going to create an entry. MeshSync is going to send the data to its database, to Meshry server. So yeah, there will be the relation. We can figure out from there that if a certain thing is actually present in the cluster or not.
Good. Okay. So then it comes down to like in this case, like a GraphQL resolver to run a query to show the active number of deployments.
Mm-hmm.
Cool. Okay, that's for another time. Okay, as we go to wrap this call, anything that we missed? Sayaten, you're going to take a poke at making the release, which is great. You'll need a little bit of instruction, I suppose. And so that's something I can show you just after the call, actually on this.
Yeah.
Okay.
Yeah, I will stay.
Okay, so we'll catch up on this same call afterward. But and everyone's welcome to stay if you want to see how to make a release. But otherwise, it sounds like that's a wrap. So that's a healthy WebAssembly filters call. So okay, thanks everybody. Yeah, no, go ahead.
Yeah, just one thing, like we probably missed that for the service meshes which don't define the CRDs like Istio does. Thoughts on that?
Yeah. So yeah, that's a great. So we have examples of that, of our approach to that using Istio, which is, I think there are like 3 or so operations. One is enabling or disabling MTLS. Another one is like enabling or disabling automatic sidecar injection. I think those are 2 examples of configuration that Meshry performs of Istio, but those configuration items are not custom resources. They're just configurations of Istio's control plane. Utkarsh, where's the best place for people to familiarize with that approach? And is that approach something that we can dynamically extract? Can we convert those into?
So the issue with those approaches, for example, automatic sidecar injection is just the labeling, and that is just patched. The issue with which we will encounter with configuring Envoy on the fly, if there is no CRD, is that Envoy is going to accept configuration from upstream, the upstream which actually basically which configured initially. So the issue would be that if there is no CRD to communicate via Kubernetes API to the Envoy, then I mean even I will have to actually look at how we can instruct the control plane of that particular Envoy to actually pipe that configuration to Envoy. The reason we cannot use those previous approaches because they rely on patches. So we can definitely patch something if there is a resource to patch, or they rely on labeling. Actually, MTLS is patching, and that is labeling.
Yep, makes sense. I don't know that everybody else, like the way that you, but yeah, so Rudraksh, there's a couple of other, like there's general approaches that of how you configure applications that run on Kubernetes. So one of those is sometimes applications will use labels and the key value pairs in those like annotations within the manifest files used to run that that workload, that application on Kubernetes. Some use custom resources, some use annotations like labels inside of manifest files. And so for those service meshes that don't have everything described in a custom resource, yeah, we'll have to we'll have to have a common approach to manually describing. We'll have to create our own JSON schema to describe those. But we already have a bit of a model for what that looks like. Like if that's just applying a label to a namespace, that's one way of configuring how a mesh works. If that's annotating patching a manifest or adding an annotation to a manifest, that's another way. And actually that very common approach like that we'll find that we need some of those for every mesh. And some of those will just have to be hard-coded in that sense. And that's actually generally, it will be okay. Generally, those are like permanent, long-lived considerations that a service mesh has chosen. They chose not to use a CRD, but to describe that, to describe its behavior over here. And generally, they don't shift away from that. Sometimes they do. Console is an example of a mesh that's shifting away from some of its configuration requirements in terms of like what gets added as an annotation. So is that satisfactory, Rudraksh, in terms of
Yep.
Okay. And be honest. It sounds like you are being honest.
I guess I've seen this happening with console, like ImageHub worked like this earlier, I guess.
Yeah, that's right. Exactly. Yeah, okay. Yeah. Cool, okay. Thanks for bringing that up. All right, well, we're definitely over time. I'm gonna say thank you everyone for coming. I'm gonna stick around for another few minutes to show how to do a release so Sayatan can do that. But otherwise, we'll catch you all next Monday. Right. Thank you all.
Thank you. Bye.
Thank you.
Bye.
So this process of making a release is it's universal for us in our approach. It's universal across all of the repos. The particular utility that we're talking about creating a release for, it's in this repo, cube open API JSON schema, because neither Utkarsh or I have more of an imagination than that. So in that name. Okay, so we try to streamline releases such that release notes are auto-documented. And we have unit tests and integration tests that are performed as part of a release that pushing whatever those artifacts that are published are pushed to different distribution points. So most notably Docker Hub, or integrating with Scoop for Windows, or Homebrew for Mac and Linux. And sometimes the artifacts, the repository is GitHub. And so in this case, for this particular artifact, what we'll end up with is a binary. Kind of like Meshry-CTL that just produces a small binary. And what we'll end up doing is releasing that binary on GitHub. So, okay, there is a couple of things to be concerned with. So one is, under the assumption that we have a workflow that builds, compiles this utility and produces a multi-architecture, multiple binaries for different architectures. Right now, it's not horrifically concerning that we would produce multiple architectures, because for the most part, the concern here is, or the reason we're producing the binary mostly, is to feed and be used by Meshry adapters. So whatever architecture those adapters are uniformly using, that's probably the architecture that we want to go for. And so basically, you guys we already have that segment of the workflow that we were just looking at earlier. Like, well, you already have a segment of a workflow that builds the thing and produces and so unless Rudraksh or someone else on the call has a different perspective as to how those should be built, then you'd use that same section of the workflow. Like, you'd probably end up with, what we'll probably want to do is create a new workflow file that's for purposes of building and releasing. So not just, this is poorly named, but not just building, which is kind of what this one is for, but the other one would build and release. And the release part is that the artifacts need to be published on here under releases. It literally, if you go make a what the heck? Do we already have this? Did you do this manually, Utkarsh, or he's not on? So that's the first thing to go figure out, is like, do we have the utility to build these EXEs? And he's got multiple architects, so Windows, and so we probably do. I'm assuming that's part of so assuming that if the workflow is there, great, to make a release, literally then what you'll end up, because of the automations that we have in the system. By the way, all this is described, like, we've got a lot of description about our build and release process, and the release channels and all that is described. Well, you can find docs in Google Doc Drive, but also in Meshry docs, there's a whole long page on what a lot of this is. What you end up doing is, if it's like, okay, it's time to make a release and we're okay, and then like, we're good, we're ready. Today, you won't have the permission to see this, but tomorrow or later today, we'll get that changed such that you'll be able to come in, you'll click edit, and you'll click publish. That's actually how you make a release. That's it, edit, publish. A workflow that will kick off based on this release event, and then compile the binaries and then deposit the binaries just where we were, right inside of, right down here. So the actual act of making a release is like, extraordinarily easy. It's 2 button clicks. And it's intentionally left manual because we're not automatically releasing all the time. We actually do make automatic releases of Meshery. That's the Meshery edge release. Every time a PR is merged, a Meshery release happens on the edge release channel. On the stable release channel, a stable release for Meshery is only done when someone comes in and manually versions it and releases it. There's a lot of automation behind what's happening here. Like this whole thing is auto drafted. This number is auto created. Sometimes it's not appropriate. In this case, for this particular thing, we really don't care that much about the version numbers. And generally we have a naming scheme where you would put in the name of the thing and first, and then you would put in the version number. In this case, the name of it's so ugly and long, it doesn't really matter. Like this is just some back-end utility that we're not looking to build out a major project around. And so to summarize, Sayatan, the way that the release is made is edit, publish. That kicks off a workflow that would run here. It's the workflow that's the question. It's, okay, do we, here, let's do it. Like, it may be that there's no need for any changes in the workflow, that we're good already. If I'm going to make this release, not to steal your glory or take away the button clicking from you, but to confirm whether or not the build process that's running now is going to, oh, okay, see, yeah, there's no build process running. So that does mean that there needs to be a new workflow written. That does answer the question that the current release that's of the current binaries that are out there, these were hand generated by Utkarsh and then uploaded. And so we may need to, you know, so that's what we want to automate. That's what your challenge will be. So you can attach binaries here if you manually build them. But the challenge will be creating another workflow. And I think you're well equipped to understand what I've said to be able to go do that.
Yeah, like we need to create a workflow to run this thing.
Yep.
This is missing in this repository.
Yeah. And it is.
Yeah, like I will try doing it, like creating this workflow.
Okay. And like it should be the case that it should be really like copy from what you're doing in the open service mesh, the workflow there for building the thing. Looking at other repositories and how they trigger off a release event. And like it's just copy and paste from a couple of different workflows to get to the point where you're then persisting the artifacts as part of the release. Cool. Does that help? Enough to get you going?
Yeah. So now I don't need to make a release, right? After.
Well, the thing is like, even though I technically made a release, it doesn't actually have the binaries there. Like GitHub will automatically zip up the source code, the contents of the repo and attach them, but these are not built into binaries. So the only available binaries are those that are right here. And of the change that went through, Anshu had helped, he made a change in the repo, but this isn't material to the way that this utility works. So there is actually there is actually already a binaries available to run. And these are the same binaries that you're referencing in your workflow today, in the open service mesh workflow. So yeah, I'm not sure. I guess I'm not even sure why there was a release needed. I think what these guys, I think Utkarsh was just acknowledging like we don't have automated release going on. So the next time that we do make an update here, that it's, you're not, we won't be able to go easily grab the binary, because normally what you would do is in the workflow that is being built into the adapters, you would say, okay, go grab the latest copy of the binary that's appropriate for that Linux-based environment, probably this one. Go grab the latest copy. You can pin it to a certain version, but then that workflow gets fragile. So you'd always want to have on the latest. And so we're missing a workflow. So it's not the most urgent of things, but it is needed.
Yeah, I got it. Like in this release, we don't have that files, right? .exe yet.
Right. Right. And if you go to like, and normally, yeah, the other workflow that you have, you'd normally go to the URL, like latest release. And so if you take the URL, then releases, I think if you just did latest, yeah, then GitHub dynamically figures out what's the latest and then redirects you to the latest. And so that's why it's important to have it auto publishing.
Okay.
So it's not, yeah, not having it right now is not a blocker, but it's something that we would want to do. So hopefully this helps create a workflow that triggers on. Does this make sense? So there's the only thing I think that isn't copy and pasteable is probably this right here, but this is tried and true. Like there's all kinds of other workflows that do this. I think otherwise the rest of this is you can copy and paste from other workflows that we have. This one, you might have to look at like just the example copies. So from.
Oh, yeah, okay.
Nice. Anybody have any other questions, or Sayatan, are you good to go?
Yeah, Lee, I think now I'm good. I understood how to make it.
Cool. Okay, nice. So as and when you get there, yeah, eventually when we're ready to test it out and do another release, then we'll get you in so that you can do the back end of doing the honors, if you will, of clicking the button.
Yeah, I will try this one. Actually.
Cool.
I will. The next time you make a release, please inform me once. I will try it out.
Nice. Okay. Cool. Well, it was nice to see all you guys. I'll catch you on Wednesday's call.
Okay. Bye-bye.
Okay.
Bye.
Bye, guys. Bye.
Bye-bye.